Welcome to my fourth video of thermodynamics, and for this video the title or the topic which we are going to discuss is quasi-static process. Okay, so as a continuation of my three videos in this course of engineering thermodynamics, only fundamentals have been covered, and now we are now just entering into the real subject or real course about engineering thermodynamics. So let me continue with the various terminologies of state, path and processes, which was already described in the last video about the state is nothing but the condition of the system before and after a particular process which has been crossed by that reaction. And this state is described or it was expressed in terms of the properties like temperature, pressure, density, composition, everything. Okay, and also I have compared this with your real-time example of what is your mind state before and after the class, or before and after a particular incident which you have came across, like. Okay, then next, and another one more very important condition is this state could be pointed or it can be plotted in coordinate only if it is in the condition of thermodynamic equilibrium. Okay, then path is nothing but the locus of series of states through which a system passes in moving from initial to final state during a particular process. Is nothing but very simply you can tell that during the class hours of 1 hour, how the path was, how the time has been passed, whether it was useful, how was it affected, that is only knowledge gaining or along with some applications or problem solving, how that path or that 1 hour has been crossed. Okay, like that, how that reaction was taken place. Okay, locus of series, locus means it is the continuous points of equilibrium, that is thermodynamic equilibrium states during the process means a particular work, okay, a particular reaction or a particular testing status before and after, what was the state of the system. Path means how that reaction had the effect on the properties. Okay, so why we are talking here is the locus of series of states means continuously how that state has been changed during that particular process. Okay, that was the importance of this path. If you want to describe a particular process completely, one should specify the initial and final state. You can tell here in this first example, you can able to see that mass is same 2 kg 2 kg from in both state 1 and state 2, but temperature is being increased from 20 to 25 degrees Celsius, and volume, as you know very well, temperature increased means the volume would be also increased from state 1 to state 2. This is the initial and final condition of that process, a particular heating process, any process which has been conducted to analyze this system. Okay, so here same type of example. Okay, here P2 equal to P1 since the process is constant pressure process. Okay, here V3 equal to V2 constant volume process. Okay, like that the end states after that particular process is completed. Okay, now next, so state, path, process is a event path is how that event was taken place. State is before and after and during the process. What are all the various states or change of properties for that process? Okay. Thermodynamic cycle. Okay. Cycle means as you are using the cycle, the wheel rotation, it starts and ends with the same condition, same place, right? And right now, like that. Here the process is defined, so the cycle is executed by the system if the number of processes, any processes, number of processes in sequence as a series of processes taken place to bring back the system to its original condition. Initial and final conditions or states are identical. Okay, so this is the here you can see this is initial state of a process, final state of a process. This is the process path. That is, this is the locus of continuous series of equilibrium conditions. Here you can put a dot. Continuously it got the thermodynamic equilibrium states. It has crossed. Okay. When you are compressing this piston, okay, you just assume that here air or any gas has been filled and now you are compressing. So during the compression, volume is reduced and pressure is being increased, and how that reaction takes place was explained in this diagram. And here cycle means initial to final and final to initial condition. It has started and stopped in the same state, means then it is called cycle. Here you can see another one more diagram for cycle, which is shown as 1 to 2, 2 to 3, 3 to 4, 4 to 1. Again it has stopped in the same initial condition, then it is called a cycle. Okay. Then processes, again some more diagrams have been given to detail about the topics which we have came across. Here you can see this is state 1 and state 2. And this is only the path of the process. This is a process, but here 1 to 2, 2 to 1, again it is returning to its initial or original condition, then it is called cycle. Okay, this is process, this is cycle. Okay, then now we are entering into a very important or vital part of thermodynamics is quasi-static or quasi-equilibrium process. Okay, this is one of a reversible process which has succession of equilibrium states and infinite slowness is its significant characteristics. Okay, that is a reversible process means a very slow process. Each and every state crossed by that process is equilibrium state. Equilibrium means thermodynamic equilibrium states, and only if you have that equilibrium, if you want to have that equilibrium state, means that particular process should be taken in infinitesimally slowness. Okay, that is in our elders or our elders would be telling you people to eat slowly. After chewing, only you have to inhale it. What is the purpose is that while chewing the food slowly and well chewing will give you good digestion, so that immediate energy and all the nutrients, necessary nutrients, will be digested or inhaled or taken by your organs. If you don't chew well, if you are eating fastly, if you are not eating slowly, means the digestion will not take place in a right manner, so that nutrients cannot be absorbed by your body. Okay, slowness is the very best tool for the effective completion of all types of processes. Okay, so here also slowness means no effect or trace of the reaction will not be stored in the system. Okay, it will not be affected. We have to conduct this quasi-static or quasi-equilibrium process in such a way that the system should not get any pain by that reaction. Okay, so the departure of the state of the system, departure means moving from one state to another state from the thermodynamic equilibrium state, will be infinitesimally small. That is, as we have already discussed, the path traced during here, it should be very nearer points. Locus should be received by you, so that the change will not keep any trace or any identity in this system. Okay, like that you have to take a very small change of state, very small change of properties. Okay, then only you can achieve this quasi-static or quasi-equilibrium process. Every state passed by the system would be an equilibrium condition. Here, well example here you can see is, instead of increasing the pressure from PI, initial pressure, to final pressure, okay, if you increase the pressure from PI and next PI1, PI2, PI3, PI4, PI5, PI6, 7, 8, 9, 10, 11 across, if you split this one into 1000 steps, means then the system will not get any affected or any pain or any traceable difference will not be stored in that system. Of course, your achievement from initial pressure to final pressure also have to be achieved as well. The system should not be affected by this reaction. How reversible? A best example for reversible processes, whenever you need to become a kid, then immediately your change of growth should be in such a way that if you need, you could be able to move to the day before of the of your age. Means that much your growth should be very slowly done, that much all the reaction should be done. Okay, it should not leave any traces in the system. Okay, means then it is called quasi-static or quasi-equilibrium process. Here another one more very good example is here. During this compression of the piston, by if you are keeping some weight over this piston, okay, when you are after the compression, when you are releasing this piston directly from one point to another point, if you keep that mass as a steps of weight and taking out one by one, means slowly this piston will be released and the expansion takes place, right? So that you can achieve the quasi-static or quasi-equilibrium process. Okay, very slow reaction or infinite slowness is only our is the quasi-static significant equilibrium. Each and every state passed by this quasi-equilibrium process should be an equilibrium condition. Okay, equilibrium condition means it is in balanced with temperature, chemical and pressure. Okay, so change in the state from one point to another point is infinitesimally small. Okay, so here locus of series of equilibrium states only can draw in the plot, right? Here you can see quasi-static means very slow reaction. Okay, spontaneous process means automatically they are irreversible process. Spontaneous process means whatever happens, all natural reactions are coming into play and they are called as spontaneous process. Okay, isobaric, isochoric, these are all the things I will explain you later. And the quasi-static process is they are very slow process. Okay, thermostatics. Here this subject named as is named as thermodynamics, that you know very well. Here one more debate is there, that instead of keeping this subject's name as thermodynamics, we can also call it as thermostatics, since we are considering only the change of the system, or all the processes should be in statistic equilibrium condition. Okay.